For this following question, we have this set, this group of formulas, and we want to. Well, we have P1, P2, and P3 as the set of propositional variables for this question, and do we want to verify if the formula phi is an equivalent to, or which is to say an equivalent, right, to the psi. So that's the question. In other words, which so I my interpretation of this, because I can't consult my teacher right now, but well, if I make a mistake on this assumption, then I will probably edit or delete this part, because we must maintain consistency and try not to propagate doubts when we do these sort of videos, educational videos. Okay, so I'm gonna presume that here the equivalent, which is to say the phi, which is notated here as in propositional notation, with the shorthand in mathematical arithmetic, which is the confusing part. And so I'm going to assume that this is the same as saying that the valoration of phi, which is the only thing that makes sense in my head right now, is the same as the valoration of psi. Actually, I've just remembered. So first off, no. This is false. It's not the valoration, it's the semantic valoration. So recall, if we go back a little bit to our definitions. So here, for example, when we were talking about the De Morgan laws, we're using the equivalency notation with formulas or variables to try to equate or to demonstrate the equivalent equation per se, or the equivalence between different notations of the same. So what we're saying is it's not exactly the valoration, although it's not exactly the semantic valoration as well, because, right, both of them, like this one, and this one, they have both different semantic valorations. They have the same, they have the same valoration, but they have different semantic valorations. And by saying that these are equivalent, then we must be saying that, yeah, it's just a, okay, so actually, rewinding a little bit, that was the initial premise. That was correct. Yes, it made sense then. It makes sense now. So it's just a different way of writing it, provides the same result. Therefore, it is the equivalence is indicating same result and different semantic valoration. Okay, right. So that's one of many confusions cleared up. So let's begin. We got phi equals p1 p2. This e is in my nationality, or what do you call it, language. It's an end. It means end. So each one of these are end. So two statements, correct? So this statement and this statement. This formula and this formula. Oops. This formula with this expression. Yeah, different ways of saying the same exact thing. So let's keep going. So we got this part, and then we got the psi, and we're saying that P1 is negated, disjunction P2, and from basic rules we know that these are in fact, using that notation, that they are equivalent. The verification can be taken from a general from an unfolding of the of one of these expressions onto the other. I find it easier to begin with this one because it's simpler to arrive at this one. So let's begin. So this is how you do it. So the negation of P1. So okay, let's already perform the first step, which is to negate P1, otherwise negate P2. Let's transform this whole thing using the negation back here. So by negating the whole thing, we obtain what? We obtain, so the negation of the negation equals P1, so no negation anymore. And when you negate the disjunction, you obtain the conjunction. So we're negating here this disjunction, we're obtaining the conjunction. Finally, we're negating this term, and this term is being negated, so the negation is nullified, and we get P2. And this is exactly the same as phi. That's done. Okay, so that's the answer, and we can move on to the next question, where B, and we got phi equals P1 and whoops, let me just be more civilized with my method of writing. So P1, whoops, P1 conjunction with the negation of P2, and then we have so we did this one, yeah. And then we have deep psi, which is the negation of P1 implying P2. So we want to see how, and we want this to verify if they are equivalent. So the answer on this one would be the in other words, 5 is equivalent to psi. Now these are more complicated, so in order to verify if they're indeed equivalent, let's backtrack to our previous mentality of testing things before trying to prove them. So let's first off, let's test that these formulas provide the same result given the same input. So P1. So we're finding that we're trying to determine before we try to prove that the equivalence is possible, we're trying to prove that the valoration will be the same. So before trying to arrive from one formula to the other, we must first try to prove that they have the same valoration. Okay, so P1 and P2, let's do their table. Next up, we want P1, okay, so P1 conjunction with negation of P2 for 0, 0. We know that this is 1 and the conjunction results in 0. And 0, 1, and we get 0, the conjunct, oops, so as you, let me be less hasty here, so 0, 0, the conjunction will be 0. Finally 1 and 0, the negation will become 1, and then conjunction will be 1. So this is a satisfactory case for this formula, for this expression, for this formula. And finally 1 and 1, and this becomes 0, and this becomes 0. So only this scenario proves to be satisfactory. Only P1 equals 1 and P2 equals 0 is a satisfactory model. And second off, we want to do the exact same for the other expression.